Good afternoon. It has been said, if you aren't in danger of missing your plane, you're getting to the airport entirely too early. Normally that I could see if that would elicit some feelings, but the spotlights here have made everybody look the same. You don't have to worry though, this talk is not about poor travel advice. My name is Glenn Harmon, and I'm here to talk to you about developing APIs on the edge. In this talk, we'll dive into the world of APIs on the edge, explore the drawbacks of traditional API architecture, and discuss how to successfully implement APIs on the edge. We'll look at some real-world examples and some ways that you can help reduce operational cost. Places that you can find me, I'm on LinkedIn, Glenn Harmon Jr. I post movie reviews and other musings at Letterboxd. I'm on Mastodon, though I haven't used that very much. If the Bird app is still a thing, that is where you can find me most often, posting about basketball or movies, or posting divisive opinions like this. A little about me. I'm a father, husband, cyclist, amateur photographer, and champion of tough conversations. I'm your guy if you need someone to tell you to get your stuff together. I'm also the VP of Engineering at Decision Desk HQ. One of the things I like to do with a lot of my friends and coworkers is I like to make everybody else feel old with me. I personally feel old all the time. My wife and I have two beautiful teenage daughters, with the oldest of which going to OSU this fall. Before, when I was walking around, I saw a couple of familiar faces, so you may already know what happens next in one of my talks. But I'm going to take the next 60 to 75 seconds to make you feel old with me. In the past, I've walked people through this graphic that shows them that the original Lion King is closer in time to the moon landing than it is today. I've used that joke quite a few times, but I can't entirely stop using that bit. So today, I'm going to use The Matrix. By a show of hands, how many of you have seen or at least are aware of this movie? I think that's everyone. This movie was released on March 31st, 1999, 24 years ago. At this stage, it's almost old enough to rent a car. That's not the part where we're supposed to feel old yet. Its latest sequel, Matrix Resurrections, came out December 22nd, 2021, 22 years after the original. If we go backwards 22-ish years, really it's closer to 21, for the release of The Matrix, we end up at the release of the original Star Wars, which puts the release of the original Matrix closer in time to the release of the original Star Wars than it is today. You're welcome for that useless information. One housekeeping item before we get into our discussion today. In Discord, there's a channel under the 1415 sessions called APIs on the Edge. If you're in one of the satellite rooms, please feel free to put any questions in there. For those in this room, you can also do the same, and we'll discuss at the end. Let's get into it. The structure of this talk. This talk, we're going to dive into various aspects of APIs and edge computing, and we're going to cover some of the following sections. Centralized APIs, we'll discuss what a centralized API is and how they've been traditionally used in web development. The drawbacks, we'll explore the limitations and challenges associated with centralized API architecture, highlighting their impact on performance, scalability, and data privacy. We're going to discuss what is the edge. We'll introduce the concept of the edge and explain how it relates to the broader context of edge computing. We'll talk about transitioning to APIs on the edge. We'll go over some use cases where people have already been doing this. We'll delve into real-world examples. And lastly, we'll get into should you do it. We'll consider the factors that you should go over when considering to make this transition from your current stack to an edge setup. By the end of this talk, you'll gain a deeper understanding of what APIs on the edge are and be equipped with the knowledge to make informed decisions about implementing them to enhance your organization's performance and competitiveness in the digital landscape. To not be presumptuous, let's quickly review what an API is. APIs, or application programming interfaces, are the lifeblood of software development. In essence, an API is a set of rules and protocols defining how software components should interact with each other. Or in layperson's terms, this is how our apps and devices talk to one another. There are many types of APIs, each with their own unique strengths and weaknesses. Some of the more popular ones include REST. This is a widely adopted architectural style for designing networked applications. It relies on stateless client-server communications using HTTP as its primary protocol. RESTful APIs emphasize simplicity, scalability, and ease of use, making them an ideal choice for web services and applications that need to handle vast amounts of data and clients. With its focus on using standard HTTP methods like GET, POST, PUT, and DELETE, developers easily understand and adopt RESTful APIs. Another common one is SOAP. This is an XML-based protocol for exchanging structured information between web services in a decentralized and distributed environment, designed with a strong emphasis on security, reliability, and extensibility. SOAP APIs are often used in an enterprise application and in environments where strict data integrity and security requirements must be met. SOAP APIs typically use HTTP or HTTPS protocols for transport, and their XML-based message format ensures interoperability between systems, regardless of the underlying programming language or platform. We have gRPC. This remote procedure call is a modern high-performance framework developed by Google. It utilizes protocol buffers, serialization format for efficient data exchange, and supports bidirectional streaming and enables low latency communication. gRPC APIs are designed for high-performance use cases requiring strict contracts between services. They are well-suited for applications that demand fast, efficient, and reliable communication, such as real-time and large-scale distributed systems. And the last of the popular ones we're going to talk about today is GraphQL. It's a query language and a runtime for APIs developed by Facebook to address the limitations of traditional RESTful APIs. It allows clients to request only the data they need, reducing the amount of over or under fetching. This flexibility leads to more efficient and precise communication between clients and servers. GraphQL is especially beneficial for applications with complex data models or requiring frequent updates and changes, as they follow more straightforward evolution and maintenance of the API schema. Let's talk about some of the common architecture found in an API setup. In a centralized API setup, we often have an API server. This core server handles incoming requests from clients and provides responses accordingly. The API server processes and routes requests to the appropriate services and databases. Speaking of databases, centralized databases store the data needed to process API requests and generate responses. These databases are usually located within the same data center as the API server. The architecture often includes API management tools. These tools help developers monitor, secure, and manage their APIs. They typically include analytics, access control, and rate limiting features. And lastly, a caching layer. Caching plays a crucial role in improving the performance and responsiveness of your centralized API. By storing frequently accessed data or pre-computed results, caching reduces the need for repetitive database queries or time-consuming calculations, speeding up an API response time and reducing the server load. For the remainder of this talk, we're going to refer to this as centralized APIs. Centralized API architectures have been deployed across various applications. Some examples include e-commerce platforms, online marketing places, and shopping websites rely on APIs to manage products, listings, user accounts, and payment processing. Social media platforms. APIs manage user profiles, posts, interactions, like your like, your dislike, and our favorite, the ability to block. Content management systems. APIs enable the creation, editing, and management of content on websites, blogs, and other digital platforms. Real-time communication platforms. APIs facilitate instant messaging, voice, and video communication and real-time collaboration tools, ensuring seamless user interactions and efficient data exchange between devices and servers. Weather and mapping services. APIs power the retrieval and display of real-time weather data, map information, and location-based services, enabling users to access up-to-date, accurate information on various platforms and devices. Our last example is going to be video streaming platforms. APIs facilitate the delivery and management of video content, handling user authentication, video playback and recommendations, and ensures a seamless viewing experience across devices and networks. APIs have taken on an even greater significance in today's hyper-connected world. With the increasing complexity of applications and the rapid growth of IoT devices, APIs are the glue that holds everything together. They allow seamless integration between various services, platforms, and devices, creating robust and interconnected ecosystems. APIs have become the foundation of modern software development, driving innovation and transforming our interactions with technology. While centralized APIs are widely used, we need to understand some of their drawbacks. In a centralized API architecture, the physical distance between end users and the data center can lead to increased latency and slower response times. This can negatively impact the user experience, particularly for applications that require real-time processing and responsiveness. Scalability. As the number of users and requests grows, centralized API architecture can need help to scale and meet the increasing demand. Scaling up server infrastructure and databases can be costly and resource intensive, making accommodating rapid growth and fluctuating traffic patterns challenging and costly. Data privacy and security concerns. Transmitting data across long distances and through multiple networks can increase the risk of data breaches and privacy violations. Centralized API architecture can also be more vulnerable to single points of failure and targeted attacks, as the entire system relies on a single location. These drawbacks have led developers to explore alternative architectures, such as APIs on the edge, which can address many of the challenges inherent in centralized systems. So what is the edge? For this presentation, we're going to talk about two components of the edge, the network edge and edge computing. The network edge, which refers to the point where a device or a local network interfaces with the internet, is situated in close geographical proximity to the device. In this graphic here, those will appear as edge nodes. Edge computing is the practice of processing data nearer to its source rather than relying exclusively on centralized data centers. This distributed approach brings computation and storage capabilities closer to end users and devices. It offers several advantages such as reduced latency, enhanced scalability, and improved data privacy and security. By enabling real-time processing and analysis, edge computing is critical in applications that demand immediate responsiveness. For those of you with smartwatches, using any health monitoring feature is an excellent example of edge computing. I'm getting away with it at the moment because I'm cheating and using AirPods in my ear to deal with the feedback. How this differs from traditional cloud computing. It's important to note that edge doesn't replace cloud computing. Think of it more as a complementary step. Traditionally, cloud computing relies on large centralized data centers to store and process data, while edge computing takes a decentralized approach, distributing the processing and loads across multiple edge nodes. This fundamental difference allows edge computing to address some of the limitations inherent in cloud computing, such as latency and bandwidth constraints. In addition, edge computing provides a more resilient and fault-tolerant system, as the failure of one edge node does not necessarily disrupt the entire network. In contrast, cloud computing on its own can be more vulnerable to single points of failure due to its centralized nature. Overall, edge computing offers a more flexible and adaptive solution for modern applications with demanding performance requirements, complementing and enhancing traditional cloud computing capabilities. APIs on the edge combine the power of APIs and the advantages of edge computing to create a powerful solution for modern applications. Developers can leverage the benefits of both APIs and edge computing by hosting and processing APIs at the network's edge, closer to users and devices. This combination enables seamless communication between software components and applications while optimizing performance, scalability, and reliability. The fusion of APIs and edge computing marks a significant shift in how developers build and deploy their applications, catering to the ever-evolving needs of end users and rapid technological advancements. APIs on the edge offer numerous advantages over traditional centralized API architecture. These benefits include a reduced latency. Edge computing dramatically decreases latency by reducing the physical distance between the source of data and the processing nodes. It enhances the overall performance of the system. Improved scalability. By minimizing latency and distributing the processing load across multiple edge nodes, these decentralized APIs can handle rapid growth and fluctuating traffic patterns more effectively, enabling businesses to scale their operations more efficiently. By distributing processing tasks across multiple edge nodes, these APIs can reduce the strain on centralized servers, avoiding the need for expensive server upgrades and additional infrastructure investments. This was one of the big selling points for us at Decision Desk HQ. November general elections are the equivalent of our Super Bowl. Or for those who don't do sports ball, it is a highly watched event. We don't want to find ourselves in a position trying to correctly guess how much traffic we may see during that time. Another advantage is enhanced resilience. This has the added benefit of being more fault tolerant. Again, as a node failure will not necessarily disrupt the entire network. And then better data privacy and security. Edge computing addresses data and security privacy concerns by keeping sensitive data closer to the source, reducing the need for data to traverse multiple networks and potentially be exposed to threats. This localized approach to data handling results in more robust data privacy and security. There are some cost savings and operational efficiencies that go with this. We have lower data transmission costs. Since edge computing allows for data processing at the source, businesses can minimize the amount of data transferred to the centralized data center. This can lead to considerable savings in data transmission costs, particularly for applications that generate large volumes of data. We have improved resource utilization. APIs on edge can help businesses optimize resource usage by distributing computational tasks across multiple edge nodes. This can result in better load balancing and efficient utilization of available resources, reducing the need for costly infrastructure upgrades and expansions. Real-time analytics, APIs on the edge enable real-time data processing and analysis, allowing businesses to make more informed, data-driven decisions quicker. This can lead to cost savings by identifying inefficiencies, optimizing processes, and reducing waste across various operational aspects. Considering these points, it becomes clear that APIs on the edge can result in substantial cost savings and operational efficiencies for businesses. Implementing edge computing strategies can help companies stay competitive in today's fast-paced digital landscape while keeping operating costs in check. While edge computing offers several advantages, there are also some drawbacks to consider. Infrastructure complexity. Edge computing requires a more distributed and complex infrastructure than traditional centralized approaches. Managing and maintaining many edge nodes can be challenging and require additional resources and expertise. Data consistency. With data being processed and stored at multiple edge locations, ensuring data consistency and synchronization across all nodes can be more complex. This is like the caching problem on steroids and keeping that fresh and up to date. There are some security concerns with APIs on the edge. The distributed nature of edge computing presents new security challenges. Ensuring the protection of edge nodes at the data they process can be more complex than securing a single centralized data center. There are cost implications. One downside to edge computing is that it demands more advanced hardware locally. Take an IoT camera, for instance. It needs a simple built-in computer to send raw video data to a web server in a centralized approach. However, the camera would require a much more powerful computer to run its motion detection algorithms than it would in a centralized setup. This added hardware need can result in higher expenses, increased energy use, and potential hurdles in maintaining and in managing those devices. Limited resources. Edge devices and servers may have limited computational and storage capabilities compared to centralized data centers. This can create constraints on the complexity and size of the applications and can effectively be run at the edge. Despite these drawbacks, edge computing can still offer significant benefits for applications that require low latency, high performance, and real-time processing. The key is carefully evaluating the specific use case and weighing the pros and cons before implementing an edge computing solution. The TLDR of that long spiel. Transitioning to APIs on edge offers a more flexible and adaptive solution for modern applications while demanding performance requirements. By addressing the limitations of centralized API architectures, APIs on edge provide an innovative and effective approach for developers looking to build cutting-edge applications that meet the demands of our increasingly connected world. APIs on edge are particularly well-suited for applications that require high responsiveness, seamless integration, and real-time processing capabilities. Multiple edge computing platforms and tools have emerged to support the development and deployment of APIs on the edge. Some of the most popular options include AWS Wavelength, an edge computing service that enables developers to build and deploy applications closer to their users for reduced latency and improved performance. AWS Local Zones extends AWS infrastructure services, APIs, and tools to the edge of the cloud and are designed to support applications that require single-digit millisecond latencies. AWS offers databases like Amazon RDS, and Amazon DynamoDB, and Amazon Aurora that can be used in conjunction with these edge services. Microsoft Azure's Edge Zones provide developers with tools and services to build and deploy applications at the network edge. It aims to optimize response times and deliver low latency experiences. Azure SQL Edge is a small footprint, containerized database engine optimized for edge deployments. It offers data streaming, time series, advanced analytic capabilities, and it makes it perfectly suitable for edge scenarios. Google Cloud Anthos is a hybrid and multi-cloud application platform that enables developers to build, deploy, and manage applications more across different environments, including edge locations. Google Cloud Firestone is a NoSQL database that can be used with Anthos to provide a scalable and flexible data storage solution for edge applications. Cloudflare Workers and Workers KV, a Decision Desk favorite. Cloudflare Workers is a serverless platform that allows developers to build and deploy applications at the edge of Cloudflare's global network, leveraging edge computing for faster performance and enhanced security. Workers KV is a distributed, eventually consistent key value store available to Cloudflare Workers. It allows developers to store and retrieve data at the edge, providing low latency across access to applications. Edge computing can be seamlessly integrated into a vast array of applications, products, and services. Some potential use cases and devices include security system monitoring. Edge computing can play a pivotal role in enhancing the efficiency and responsiveness of security systems. For instance, a smart security camera with edge computing capabilities can analyze video footage locally, identifying and alerting users to potential threats in real time without relying on cloud server for processing. This reduces latency, minimizes bandwidth usage, and enhances data privacy. IoT devices. Smart devices connected to the internet can benefit from running code on the device itself instead of on the cloud, resulting in a more efficient user interaction. Again, I reference your smartwatch. Enhanced caching. By executing code on a CDN edge network, an application can tailor its content caching strategy, efficiently delivering content to users. Medical monitoring devices. Real-time responsiveness is crucial for medical devices, eliminating waiting for a cloud server communication. Video conferencing. Interactive live video consumes a significant bandwidth. Moving back-end processes closer to the video source can reduce lag and latency. AR and VR technologies. The immersive nature of augmented and virtual reality experiences require high performance and low latency to maintain user engagement. By leveraging edge computing, AR and VR applications handle complex graphics and interactions closer to users, minimizing lag and ensuring fluid and captivating experiences. This is usually crucial for applications like gaming, training simulations, and virtual collaboration platforms. Some use cases across industries: autonomous vehicles. Self-driving cars rely heavily on real-time data and processing to make decisions, which make APIs on the edge the ideal solution. Companies like Tesla and Waymo have embraced edge computing to facilitate rapid communication between their vehicles' onboard computers and cloud-based services. This enables faster response times and improved safety. Web technologies like WebSockets and WebRTC are employed to enable these low-latency communications between the vehicle and the cloud. Smart cities, local government, and urban planners are increasingly turning to APIs on the edge to optimize urban infrastructure and improve the quality of life for their citizens. This includes projects like intelligent traffic management systems, real-time air quality monitoring, and responsive public transportation networks. Web technologies such as progressive web apps and real-time APIs enable seamless integration and interaction between various components of a smart city. Manufacturing. The manufacturing industry has embraced APIs on the edge to optimize their production processes and enhance their supply chain management. Companies like Siemens and GE leverage edge computing to enable real-time data processing and analytics. This helps them facilitate better decision-making and increased efficiency. They employ web technologies like RESTful APIs and GraphQL to use for the exchange of data between edge devices, cloud services, and manufacturing systems, enabling streamlined operations. Online gaming. Online gaming platforms have turned to APIs on the edge to provide low latency, responsive game experiences to their users. If you've ever played a Halo, an Overwatch, Call of Duty, or Fortnite, you know the importance of low latency. Game developers and service providers utilize edge computing to process game data and interactions closer to the players, minimizing lag and ensuring a smooth gaming experience. Web technologies such as WebSockets and WebRTC play a crucial role in enabling real-time communication between game servers and client. This one's a plug for Decision Desk and how we've benefited from APIs on the edge. Utilizing this strategy, we've been able to supply our clients with reliable access to election results via our API, our embeddable results for their web publications, and our own results site. On a general election night in November, we are getting billions of hits across our various offerings, and the reliability of services during those high traffic hours is of the utmost importance to us. These examples demonstrate the power and versatility of APIs on the edge across different industries, showcasing their potential to revolutionize the way modern applications are developed and deployed. This is how I imagine people feel after implementing APIs on the edge. As we begin to reach the end of our journey exploring the world of APIs on the edge, you might be wondering if this is the right path for your organization. Let's dive into some critical factors to consider when deciding whether or not to implement APIs on the edge. Performance requirements. We've talked about this in some way or shape a lot of times already, but carefully evaluate the performance needs of your application. Ask yourself whether they are susceptible to latency or if real-time processing capabilities are essential for optimal functionality. This answer may be no. If these factors are critical to delivering a smooth and efficient user experience, migrating to APIs and Edge could significantly improve your application's responsiveness and overall performance. Data security and privacy. Reflect on your application's data privacy and security demands. Edge computing can deliver improved security and privacy by retaining data near its origin, thus minimizing the need to travel across various networks. In addition, if your application handles sensitive information or must adhere to strict data protection regulations, implementing APIs on the edge can provide a more secure solution and better safeguarding of your data and your client's data while maintaining compliance. Consider the anticipated growth and traffic fluctuations your application might experience. APIs on the edge offer enhanced scalability and are adept at managing rapid expansion and varying traffic loads. They can handle this more efficiently than a traditional centralized architecture. If your applications are likely to experience substantial growth or face unpredictable usage patterns, adopting APIs on the edge can help ensure optimal performance and a seamless user experience even through periods of high demand. For infrastructure costs, we have to assess the expense of establishing and maintaining an edge infrastructure for your applications. Although implementing APIs on the edge can result in long-term cost savings and operational efficiencies, the initial investment required to build and deploy the necessary infrastructure might be significant. When deciding, weigh the potential benefits against the upfront cost to determine if transitioning to an API on the edge is a financially viable option for you and your specific use case. Finally, in today's swift changing digital landscape, staying ahead of the curve is essential to ensure success. APIs on the edge present a groundbreaking approach to address the limitations of traditional centralized API architectures, delivering enhanced performance, scalability, and security. By adopting this technology, your organization can establish itself as a frontrunner, gaining a competitive edge and promoting growth in an increasingly fast-paced digital environment. Evaluate the potential benefits and challenges for your specific use case. Each organization has unique needs and goals. Take the time to carefully assess how APIs on Edge can align with your business objectives and requirements. Consider conducting a pilot project or proof of concept to evaluate the feasibility and potential benefits of this approach in your specific context. As we conclude this talk, let's take a moment to recap the main points we've discussed. We started by defining a centralized API, examining the drawbacks associated with this approach, such as latency, scalability, and data privacy concerns. We introduced the concept of the edge. We discussed the benefits of edge computing, including reduced latency, improved performance, and enhanced security. We explored transitioning to APIs on the edge, covering popular edge computing platforms, crucial steps in development, and best practices. We delved into various use cases, demonstrating the transformative potential of APIs on the edge across different industries. We discussed the cost savings and operational efficiencies that APIs on the edge can offer, helping organizations optimize their resources and minimizing expenses. And lastly, we considered factors to weigh when deciding whether or not to implement APIs on the edge, emphasizing the importance of evaluating the potential benefits and challenges for your specific situation, and encouraging the exploration of this concept within your companies. I hope you've gained some valuable insight in the world of APIs on the edge and feel inspired to investigate the possibilities it presents. Edge computing is a rapidly growing field with immense potential. We can harness its full potential for improving our digital experiences by staying informed and engaged. Thank you all for your time and attention today. Please don't hesitate to reach out to me if you have any questions or want to discuss the topic further. I'm always happy to engage in a thought-provoking conversation and share my passion for technology and innovation. Thank you.